All right. Hi, everyone. Okay, so just before we get started, just by show of hands, who's already using OpenTelemetry? Okay, cool. Hopefully this will have something for you. We're going to go on a little bit of a deep dive of like the mechanisms under the hood that make auto-instrumentation in OpenTelemetry work, and hopefully demystify it a little bit. And so let's dive in. Oh, no, don't do that. Oy. Sorry about that. Okay, I don't want this to be a mouse. Okay, much better. Hi, I'm Josh. I work at Altinity, and just for the lawyers, I have a little thing there. We are not the maintainers of ClickHouse. ClickHouse is. We are open source contributors, and we have a hosting platform and offer managed service for ClickHouse. So let's talk about observability, though. That's what we're here to talk about. I'm guessing this is the third of the room that this morning raised your hand when she asked who was using OpenSearch for observability use cases, so thanks for coming. So just to level set, right? This is kind of the classic definition of observability that I'm sure you've seen from other influencers, right? It's really just about our ability to understand a system without going in and changing the system, right? If the system already gives us enough information coming out that we can understand the operation and then pull the levers that we need to in order to make it operate the way that we want it to operate. So that's really the goal here at the end of the day, is just to be able to understand what's going on. And in order to do that, right, we have this is kind of an excerpt from a talk that I'll be giving tomorrow, and also something that I talk about a lot, which is like how we build a whole complete observability solution around storage technologies like ClickHouse or OpenSearch, around collection and sampling tools like Kafka or the OpenTelemetry collector, right? So this is a very, very rich ecosystem. But today, specifically, we're talking about auto-instrumentation, which mostly on this graph lives within that little application SDKs box all the way over there on the right. So that's where we get the actual information about the runtimes, right? The information that is maybe relevant to the developers maintaining the application about how their application is running, right? We want that context as well as any context that we might need from the infrastructure and so on. So this talk I first gave maybe a year and a half ago, and it stemmed from some questions that I got from one of our salespeople. I was working at an observability platform at the time. And he had these specific questions that were coming up over and over again with his customers when they brought up auto-instrumentation, whether it was with our proprietary tracing or with OpenTelemetry tracing. And so the most salient questions is like, do I need to modify my code in order to use this? Does it work if I'm using completely custom code, or do I need to use like specific libraries and tools? And I see that, especially in the world of OpenTelemetry, the Kubernetes operator gets mentioned a lot when we're talking about open instrumentation. So will this work without Kubernetes? And if these were all yes or no questions, this would be a pretty short talk. So it depends. Let's dive in. So what we're going to talk about, right? First, what are we trying to do here? What's our goal? Why are we even doing auto-instrumentation? What is it? And hint, there is more than one right answer to what auto-instrumentation is. But I'm going to try and hopefully give you some words to describe the different kinds of auto-instrumentation so that we can talk about them sanely and make sure that we're all talking about the same things. We'll talk about the different kinds of auto-instrumentation, how it works in all the various different programming languages that support auto-instrumentation in OpenTelemetry. We'll talk briefly, very briefly, about the Kubernetes operator, which is a way to leverage auto-instrumentation, but it's not required. So we do already have an answer, actually, to that third question. And then we'll talk about when we need a little bit more than auto-instrumentation and when auto-instrumentation really, really shines. And we'll have kind of a decision tree for, like, should I use this? OK? So instrumentation, right? It's really just the process of translating whatever interesting things are happening inside our code, inside our applications, inside our systems, into telemetry signals. Metrics, traces, logs, profiles, right? It doesn't matter what telemetry signals, right? But it's just we want interesting things into signals. That's what instrumentation does. A lot of the time we're doing it manually, right? If you have a line of code that emits a log message, that's manual instrumentation. Great. But that's not scalable, right? We want to actually understand everything that's happening throughout our entire system. And when we're talking about OpenTelemetry, usually that means that we're talking about distributed tracing, and the things that we care the most about are HTTP calls, right? One service calling another, whether that was initially kicked off by an end user in the front end, or it's a backend service talking to another backend service, talking to a database, or what have you. So we've got our client, we've got our backend service, right? And there's an HTTP call. There's some headers, probably your OpenTelemetry, right? Trace propagation headers and everything else. And then we want to know that that happened, and we want to annotate that and log that somewhere. So we've got some other stuff that's like looking at that and emitting spans in this case, right? Because we're talking about distributed tracing, so we're emitting spans. Now, I will say, auto-instrumentation, right? Those googly eyes are kind of doing some magic to observe another process outside of the process that they are running in. And that's what we're going to talk about, how that sort of magic works, so that it's not just magical googly eyes. But that's not the only way to do this, right? Actually, probably the best way to have instrumentation, in this example where we're using Express, would be to have the Express library, because it's a very popular and common library, right, to have it actually directly call the OpenTelemetry API. That would be the best case, is to have the maintainers of libraries, if you're a maintainer of OpenSearch and you're here, please take note, right, directly talking to the OpenTelemetry API with instrumentation that was designed by the providers of that library. And this is actually one of the beautiful things about OpenTelemetry, is that it shifts the burden of instrumentation from observability vendors to library providers, which makes sense because the library providers have a lot more context, right? So I said that telemetry, right, is the process of translating interesting things into telemetry signals. So what are the interesting events? Well, in the context of tracing, in the context of our applications, we're talking about requests and queries and messages. Pretty much all of those are going to be some kind of network call, right? We're talking about errors, exceptions, and events. Those are usually some kind of log message, right? And really, we're talking about, in some cases, we might be interested in very specific function calls, right? If there's a function that's doing a lot of heavy lifting for us that's specific to our application, we might be interested in emitting some specific spans for that. But actually, if we think about it, right, all of those other things, requests, queries, messages, errors, exceptions, and events, those are all kicked off by functions. So if we're talking about observing application code, really, all we're talking about is, can we observe function calls and emit telemetry events for that? And if we can do that, then we can cover all of those other use cases with the full context of the application stack that we're running in. That context is really important, right? And we're going to talk at the end a little bit about things like eBPF and some things that work outside of the application stack and in either the kernel or the network stack in order to do your auto-instrumentation. And those tools are really powerful because they're always comprehensive, because they're a layer down the stack. But they're also missing a lot of this really important context, right? We want to know who the user was. We want to know metadata about the user. Not identifiable metadata, right? We don't want PII, but we do want to know like what the user's goal was, what part of our funnel or flow they were in, right? And what they were trying to do, and if they got any errors along the way. We need to tie all of this back to the infrastructure that it's running on, right? And that context doesn't necessarily exist inside the application runtime, although it can, using things like OpenTelemetry resource detectors, which are really powerful. And then this last one is a little bit aspirational, but I encourage you to explore it. It's organizational context, right? Tagging things with the people or the teams that are responsible is a really, really powerful way to organize your telemetry so that right, you kind of have pre-routed your incidents if you can do that effectively, although it is challenging to do that across an entire large organization. Okay, so I talked a little bit about this. I'll go into slightly more detail, right? So in OpenTelemetry, we have, oh, these are out of order. Oops. Okay, so we have the OpenTelemetry SDK. This is the thing that we actually put in our code that provides an implementation, right? This is the thing that we put in our application if we are the developers of the application running a specific instance of it, right? If you're the maintainers of the Express library, you don't put the SDK in, you just put the API in, and it comes with an out-of-the-box no-op implementation of all of the functions so that your library can safely call them, and it will work in anyone who's using that library's code until they provide a specific implementation with processors and exporters that they want to use using the SDK. And then finally, we have these things called instrumentation libraries. And these are really important when it comes to auto-instrumentation. These basically translate the function calls, the interesting things, right, in our code into API calls for us, assuming that we're using a library that doesn't directly call the OpenTelemetry API, which most still don't, right? Okay, sorry, I skipped this one. Right. So the different types of instrumentation would be manual instrumentation with direct API calls, which I talked about how that is the best path if you're maintaining a library, but burdensome if you're maintaining a whole application. We have instrumentation libraries, which is great if the library that you're using doesn't come with out-of-the-box direct calls. And auto-instrumentation, right? This is still kind of this nebulous thing that I'm now going to define better. Here's an example from the OpenTelemetry demo project, right? So this is a Node.js. This is the Node.js front end API that comes with the OpenTelemetry demo project. This is all of the instrumentation for this JavaScript service, this one file. Right, it's all here. I cut out the resource detectors part, but that's just a 12-line array of different resource detectors that you would use for like AWS or different environments that you're running in. That's pretty cool, right? And there's that word there, auto-instrumentation, right? So isn't this auto-instrumentation? If we've got the word right there. I would probably call this auto-instrumentation, but it's also not what people are often referring to when they talk about auto-instrumentation, because we had to go in and modify the code, right? We had to add this to our application. And that was one of those initial questions, like, do I need to modify my code? Sometimes. In this case, yes, but there are some cases where you don't. So isn't that auto-instrumentation? Okay, so no, it's one form of auto-instrumentation. It's using instrumentation libraries, which we just talked about, right? They either modify the libraries that they're observing or just observe them and then call the OTel APIs to create telemetry from that observation. What we were just looking at on that Node.js example is an example of what I would call an auto-instrumentation meta package, right? So it's a package that just pulls in all of the instrumentation. It kind of detects what other packages you're using in your Node.js application, and then it pulls in the relevant instrumentation libraries for you, which is really, really convenient. But we did still have to modify the code. Then we have what I would like to call no-code instrumentation. And this is available to us in very different ways because the different programming languages and runtimes, right, have different ways that we can kind of hook into them from the outside. So it's any kind of mechanism where we can add instrumentation without touching the original source code. This is usually done via environment variable configuration in the case of runtimes, or in the case of Kubernetes, right, there's the operator, which will actually mutate the pods and add the instrumentation for you. And that's that last category, right? The instrumentation injection. So this is how we get that no-code instrumentation into our package, depending on where it's running, whether it's in Kubernetes or just, bare metal or something like that on a VM. So what are the different mechanisms for doing this? So we have our code-based mechanisms, right, where we're modifying the code, and then we have the no-code mechanisms. Some of them kind of look the same. So the code-based mechanisms, again, this differs depending on the language that you're working with, but we have monkey patching, which is really just like modifying the code in real time before it gets run. We have function wrapping, right, which involves kind of watching for certain functions to be called, and some languages have a mechanism for providing like hooks into that can run before or after certain function calls. In HTTP libraries like Express or Fast API, middleware injection is a really great way to pull out some telemetry from the HTTP request chain. And then event observation for programming languages that provide and frameworks that provide some kind of event stream that we can listen to. This is another powerful way that we can emit telemetry. Although one thing that event observation doesn't give us is the ability to inject the trace context for our downstream calls, which is also an important part of what we're doing here with auto-instrumentation, right? Because we need that W3C trace ID context to get propagated all the way through. And then when we talk about the no-code instrumentation mechanisms, right, for getting things into the packages without modifying them, again, we have monkey patching. This works great for interpreted languages like JavaScript and Python that are interpreted at runtime, so we can modify them right up to the moment of execution. And then we have interpreted languages that have a specific runtime, so like bytecode interpreter, that would be like Java and .NET, and actually also in some cases Python. Python's kind of weird because it uses like all of the different possible methods of auto-instrumentation. It's a really fun one. Right, but Java and .NET specifically have an agent that has extensions for auto-instrumentation. We'll talk about how that works briefly. In PHP, we have an interpreter extension which provides a hook function that we can use to hook into other functions. And then it also automatically loads instrumentation packages using the PHP auto-load mechanism. Right, it's a common pattern for using vendor tools with PHP. And then in Golang, we have the brave new frontier of eBPF. And we'll talk about that at the very end. So, monkey patching. Here is an example from the Node.js Express. This is actually the Express instrumentation library. So Express does not directly call the OpenTelemetry APIs, but that's okay. JavaScript is interpreted. We can just provide some new JavaScript around the existing JavaScript that does include calls to the APIs. And really here, when we're setting up this instrumentation library, right, we're calling this function that defines the module. We're saying this is the other library that it operates on. These are the versions that it's compatible with. And then we're providing a hook and an unhook function. So the hook function modifies the code to instrument it, and the unhook function unwraps everything when we're turning it off. And you can look through, right, the auto-instrumentation libraries for Node.js and see all of the different libraries that are supported. They're all going to have one of these definitions, right? Then we have function wrapping. So I mentioned that PHP interpreter, right? It gives us this hook function, which is great, because we can just use it to then hook in. And depending on how your PHP framework is orchestrated, right, you can hook into the function that's making your HTTP calls or your request handlers or what have you. I did an interesting experimental project where I used this to make a WordPress profiler, right? So WordPress has this do action, I think it's called, function. And you can hook into that, and then you can see every single, because WordPress uses this function internally for constructing the whole page template, you can see all of that and kind of profile it with OpenTelemetry trace spans, which is kind of cool. Don't actually use tracing for profiling, use profiling for profiling, but it was a fun experiment. Okay, middleware injection. Where's the code sample? There it is. Middleware injection. So here's an example, right, of how we would do middleware injection with the FAST API in Python. It has an out-of-the-box mechanism for providing middleware. And then we're using this OpenTelemetry concept called a tracer provider that's going to then emit the trace spans. Event observation. I love this example. This example is from Elixir, one of my favorite programming languages to use. And we see we're just attaching, right? We're listening for this specific event, in this case, the router dispatch event. And we're hooking into that. And then we have an opportunity to run some of our own code and emit telemetry matching the requests that we're observing. Okay, so those are the different code mechanisms that we can use to get instrumentation into our libraries, into our code. How do we get those things into our packages? Well, usually just like this, right? You just configure some environment variables, and if the auto-instrumentation is available for the runtime that you're using, this will turn it on, which is actually pretty easy, right? Here is a list of the languages for which it is available. So we're looking at Java, Python, JavaScript, .NET, Go, PHP, Erlang, Elixir, and Ruby. You'll notice this is pretty much all of the not compiled languages that OpenTelemetry supports. Auto-instrumentation with compiled programs is obviously a lot more complicated. Go is a compiled language that is on this list, but it does have a little asterisk next to it. Because it's still kind of experimental, although that's less true than when I first gave this talk. And we'll talk about how that works, right? And then here's kind of a breakdown of the different mechanisms that each of the different tools uses. And again, right, Python's kind of it does all the things. Okay. So bytecode injection is a way that runtime agents can basically directly inject the OpenTelemetry SDKs. Those are important, right? And with all of the configuration that you set up in those environment variables directly into your, not your binary, but your bytecode. So here's an example of how a typical Java application would work, right? You write your source code, there's a compiler that compiles it down to bytecode, and then the JVM interprets the bytecode and spits out machine code that your processor can run. And when we're doing auto-instrumentation, we just stick an agent right there. And that agent can work on the bytecode, which is still pretty human readable, right? Like it's not the original source code, but it's still human readable enough that we can, at this layer, get information about the functions that were being called, the parameters that were being passed to them, and we have all of that important user and infrastructure and additional context that we need, and we can also add additional annotations to this if we need to. eBPF, because compiled binaries can't be modified, right, we need to use eBPF. Raise your hand if you're not familiar with eBPF. Oh boy, okay, let's explain what it is a little bit. Okay, so eBPF is basically a mechanism for hooking into the Linux kernel. Now, it's called eBPF, it stands for Extended Berkeley Packet Filter. Packet filter gives us a kind of hint of the origin of this. It comes from the networking stack in Linux, and it was originally designed for networking tools, security tools, right? WireGuard actually leverages this very heavily. If you've used WireGuard on Linux, you've used eBPF. But as a mechanism for hooking into the kernel, the kernel, right, the syscalls in the kernel of other applications, this has really, really big applications for observability. A couple of notes about eBPF, right? So eBPF programs are written in a subset of C. The reason it's a subset is because we need certain safety guarantees, right? These programs are going to be run in the kernel with full permission, and in order to make sure that you don't crash other programs, eBPF provides certain safety guarantees, like that the program is guaranteed to exit. So it's not really Turing complete, but you do get this nice subset of C that you can use to do really useful things with, like observability events. So here's an example that maybe kind of helps explain what I'm talking about. This is a very basic example where we're just counting the number of packets emitted by a specific function. But you can kind of see how we could use this to hook into really anything that's happening inside the code, right? And emit metrics, emit spans, emit logs. However, it's a little tricky because at this point, we have already discarded a lot of that user space, like the names of variables and things like that. A lot of the time, it's been discarded. And also, we don't necessarily know, right, like which functions we want to hook into at this point. You can hook in like very, very low at the network stack and you capture everything, but then you've discarded even more of that context. Or you can hook in like kind of higher into your Golang stack and you have more of that context, but you don't know if there's maybe other parts of the application that are making network calls using different functions that you didn't hook into. So while eBPF is really, really powerful, there's still a lot to work out to make this as reliable as some of the other tools that are a little more mature for observability. Right, because when we're dealing with interpreted languages, I just explained this, right? We lose that. The further to the right that we go, the more context that we have, but the less sure we are that we've captured everything that's using the network. So how do we actually get this into our code, right? We use the Kubernetes operator in most cases. You can use those environment variables. That works really well with Java and Python. But the Kubernetes operator is really convenient for Java, Python, JavaScript, .NET, and PHP. It can kind of just mutate your pods and give you auto-instrumentation without you ever having to even modify your containers. There's the code example. I don't know why the code examples are taking a second to come up. Okay. So, right, there's a code example where you basically define, hey, this is how I want you to apply auto-instrumentation. Basically, you just like in anything in Kubernetes, right, we're providing some specification, and any pods that match that specification are going to get the auto-instrumentation rule applied to them. The most important thing here, right, is that we're providing some basic configuration, like where the telemetry should actually get sent once the SDK gets injected. And you have full access, right, to all of the configuration that you would normally have with the OpenTelemetry SDKs here. Because at the end of the day, that's what the auto-instrumentation is doing. Here, it's injecting the SDKs as well as the relevant instrumentation libraries. So, what have we learned? Can we go back to those original 3 questions and maybe provide some more detailed answers? Do I need to modify my application code? Well, no. But if you don't modify your application code, you might be missing some context, but you can get pretty good starting point without modifying your application code. Do I need to use specific libraries? Well, yes and no, right? You can go look at the auto-instrumentation packages for your programming language of choice, and you can see on the GitHub, there's usually just gonna be a folder that lists all of the libraries that are supported. However, it's a little bit fraught because sometimes, like in .NET and Python, the auto-instrumentation packages, right, those meta packages that we talked about at the beginning, they do some extra hooking and stuff for libraries that maybe don't have instrumentation libraries. So you have to kind of look at the documentation for the auto-instrumentation as well as all of the instrumentation libraries, and that will tell you kind of which libraries you can expect to have supported. And I would argue, if you're using a library that is not supported, the best thing that you can do for yourself and for the community is look into maybe making an instrumentation library for that library, and then everyone else who's using it can benefit from that as well. So you can dig into some of these, those code-based mechanisms that we were looking at a few minutes ago. And will it work without Kubernetes? Well, yes, but Kubernetes certainly makes things easier. All right, so when is it not enough? Which can happen, right? In observability, we want a lot of context, but I would argue, right, like, something is better than nothing, and what I've seen is that a lot of organizations are doing observability just with very basic metrics and then logs when they need them, right? Go find the logs, not even doing centralized logging, we're just going and grabbing the logs directly out of the pods. So if we're talking about that kind of organization, then auto-instrumentation is a huge, huge leg up compared to that. But it's also not enough for a very mature observability organization. We might want those specific function calls, right? If there's specific function calls that we're using that are important to us because they're doing a lot of work or because they're on a business critical path, the auto-instrumentation libraries have no idea about any of that. They know how things like HTTP calls and database calls work because that's common to every application. But the things that are specific to your application, you're going to have to add annotations in there. Now, a nice thing about the auto-instrumentation SDKs is most of the time, you can start with the auto-instrumentation library and then just go add additional annotations and add additional spans that weren't covered by the instrumentation library and still benefit from that automatically injected SDK. We also need to make sure that we have any incompatible frameworks or libraries documented. I already talked about how to do that. Like, please contribute to the upstream instrumentation libraries. And this gets really, really important if we're talking about monolithic services where we don't have network hops, right? It also gets important if we're not using HTTP as our primary network modification, because for the most part, these auto-instrumentation libraries are very, very strong for HTTP and pretty much non-existent for other things like IPC or RPC. Okay. So I think it's really important that we have manual annotation for these essential things, right? The user experience, details about the client. This is going to reflect kind of what we were talking about at the beginning, being really important, right? The things that are really important to our business, like regions or departments or revenue or cost or value from a shopping cart, things like that, that we might want to track that aren't necessarily directly related to observability, but it turns out trace spans are like a really good place to put some of that information. Team or business unit ownership, right? I already talked about the value of this and how you can kind of pre-route your incidents if you've tagged your telemetry appropriately. I think this is a really powerful technique, but again, not necessarily easy to ramp up on immediately. And then I mentioned this, right? If we're not predominantly using HTTP, if we're predominantly using something like IPC, then we might have to do this manually. And I say manually because you're still going to be better off using some of those code-based instrumentation mechanisms, right? If you can find a way to do this repeatedly throughout your entire code base, that's going to be a lot better than littering OpenTelemetry API calls throughout your entire code base. Oh, weird. They're like looking different the first time. I'm sorry. Anyways, when is auto-instrumentation awesome? When it's combined with manual annotation, right? When we're using it as a starting point and then providing all of our additional manual annotation on top of that. Filling gaps in end-to-end distributed tracing. So say you have legacy services or compiled services or third-party services that you can't modify. Auto-instrumentation is a great way to make sure that your tracing is still end-to-end because tracing is only valuable when it's end-to-end. We can really, really quickly understand system topology. So if you're working with an application that you maybe just inherited, or it's a third-party application, it's like someone's like, hey, should we install this? Can you check this out? Auto-instrumentation is a really great way to quickly see, okay, how does this thing work? Like, what's talking to what? And you know that that's actually accurate because it's coming from the network traffic, not from the brain of a senior architect, or some out-of-date documentation, right? And all of those cases, right, if we can't modify the original source code, auto-instrumentation is awesome. So decision tree, should I use this? And then we'll have about 5-10 minutes for questions. If you're working with a compiled language, your options are kind of limited, right? You're either going to have to do some kind of manual instrumentation or use eBPF. If you're working with more of a managed runtime, and you're using really common libraries, and you don't care about all of that detailed information, then just use auto-instrumentation. But in most cases, you're going to use some kind of hybrid approach where you're combining auto-instrumentation with manual annotation to get the complete detail and the complete coverage that you need. That's all I've got. So time for questions, and thanks so much for coming. Yeah.
Not sure if I'm going to use mic or...
Oh, I could repeat the question if they don't. Yeah.
So one of the applications that we deployed in one of our customers, the customer had Dynatrace, and one of the enlightening thing was seeing how the code was performing in live production because Dynatrace was injecting into the process similar to the auto-instrumentation, doing bytecode changes to the application. While this was fantastic to get an insight into the code and seeing where we had performance problems. We also experienced several times that the way they did bytecode instrumentation actually was the cause of the errors on some intricate cases. So the question is, do you have any experience with OpenTelemetry when it comes to auto-instrumentation where the actual instrumentation is part of the problem?
It can happen, right? And it's like the cardinal sin of observability. If your observability tool breaks the rest of your application, you're really mad at that observability tool. I feel for you. But it does happen across the stacks. I would say with OpenTelemetry, it's evolving very, very quickly. And the best thing that you can do is to look at the specific libraries that you're wanting to use and profile them and compare with them turned on and turned off and see what kind of performance impact you're seeing. I haven't seen OpenTelemetry like outright break things the way that some of the vendor libraries have, although this might not be true anymore because I haven't looked at it in a while, but I used to hear a lot of complaints about the PHP auto-instrumentation libraries for OpenTelemetry. It has more to do with the way the PHP runtime works than that actually being a poor tool, right? PHP is tricky.
Another question, given that we're at the OpenSearchCon, is have you ever tried running OpenSearch under auto-instrumentation?
I haven't, but it should be pretty easy, right? Because it's Java. And the Java auto-instrumentation for OpenTelemetry is extremely good. Other questions? Yeah.
Could you explain a little bit more in detail how the Kubernetes operator injects the instrumentation into a pod? I didn't get that exactly. So how does it work in the internals?
So I believe it's using a mutating webhook. So it's actually changing the pod, like when the pod, an emission controller, right? So when the pod gets deployed, if the pod matches the specification, then the Kubernetes operator will provide, I think it provides an init container, and the init container does what it needs to do in order to modify the container that actually contains the application code.
Okay.
Other questions? All right, thanks everyone.